Hello everyone, welcome to the channel Vidyut Yog. Those who are new to this channel, please subscribe the channel. So in this video lecture, actually we are going to cover the contents of Kirchhoff's law and its application to network solution using mesh and nodal analysis. Since it is not possible to cover all the points in one video lecture, that's why we'll divide this concept into 3 video lectures. So in first video lecture or in this video lecture, we'll cover the points like basics of electrical network which are needed to understand the understand to solve any network by applying the Kirchhoff's law. Then we'll go through the statement of Kirchhoff's law, and in last part we'll see how the sign conventions use and how to write down the equations for mesh analysis by using Kirchhoff's law. So first of all, basic terms related to the electrical network. So first of all, what is the electrical network? So it is an electrical configuration in which various components such as R, that is resistor, L, that is inductor, and C, that is capacitor, etc., and energy sources, that means voltage or current sources, are electrically connected to each other. So I repeat, electrical network is nothing but electrical configuration in which various components such as R, L, C, etc., and voltage and current sources are electrically connected to each other. Now this electrical network is classified into two types, that is DC network and AC network. So DC network means which operate on DC supply, and AC networks means AC mains supply. Now second point is circuit element. So it is an individual circuit component which gets connected to other components in a network such as R, L, C, voltage sources, etc. are the circuit element. For example, in this electrical network, resistor, then these voltage sources, these are circuit element. Circuit element are classified into two types, like active circuit element, passive circuit element. So active circuit element are nothing but which supply energy to the network. For example, in this, the voltage source is the active network. And passive network is nothing but which stores or dissipates the energy. Like a resistor dissipates the energy in the form of heat. So these resistors are nothing but passive circuit element. Third point is branch, which is always denoted by the letter capital B. So what is the definition of the branch? Branch is nothing but part of the network which connect various junction point is called as branch. For example, in this circuit, the AB is nothing but the branch which connect two junction point like A and B. Similarly, BC, CD, AF and BE, these are the different branches. So for the circuits 1, 2, 3, 4 and 5 branches are there. Okay. Now next point is junction. So what is the junction? It is common point in a network like A, B, C. I repeat, it is a common point in a network at which two or more branches meet. For example, at point A or junction A, branch A and AB meets. That's why it is junction point. Similarly, at point B, branch AB, B and BC meets. That's why it is junction point. Similarly, C is the junction point. And in between E and F, D and E, there is no any other branch involved. That's why E, F and D can be act as one junction point. Suppose we said that common point in this is A is the junction point. So for this network, there are four junctions like A, B, C and E. These are the four junctions. Now, next point is node. So what is the meaning of node? So the point which through which circuit element connected to the circuit is called as node. For example, this voltage source is connected through the point F or point A. Then these are called as the nodes. So in this case, A, B, C, D, E, F, these are the nodes. But there is another one important statement related to the node. If there is no element between two or more connected adjacent nodes, like here between E and F, E and D, there is no any other element is connected. So in that case, it can be recombined as single node. So for example, here we can recombine nodes D, E and F as single node, and in that case there will be nodes are A, B, C and E. Okay, so till now we have discussed about what is the network, circuit elements, branch, node, junction. Now next point is loop. So what is the definition of loop? Loop is nothing but set of branches. I repeat, loop is nothing but set of branches forming a closed path in a network. So, for example, in this electrical network, A, B, E, F, A is the set of branches which form a closed loop and that closed path. That's why it is called as loop. Similarly, B, C, D, E, B is the second loop, and third loop is outer portion of this network, that is A, B, C, D, F and A. This is the third loop. So I hope the concept of the loop is clear. Now mesh. So whenever we are going to apply the Kirchhoff's law to network solution, you should have the clear idea what is the difference between loop and mesh. So loop is nothing but set of branches forming a closed path, whereas mesh is nothing but it is also loop. I repeat, mesh is nothing but a loop, but in which no other loop is involved. I repeat, mesh is the loop in which no other loop is involved. So, for example, in this network, A, B, E, F, A is the loop in which no other loop is involved. That's why it can be considered as mesh. Similarly, in loop B, C, D, E, B, there is no other loop is involved. That's why it can be considered as mesh. Whereas in case of A, B, C, D, E, F, A loop, there are two other loops are involved. That's why it does not consider as mesh. So for this electrical network, there are three loops, whereas meshes are only two. Okay. Next point, open circuit. So what is the meaning of open circuit in case of the network? Suppose open circuit, that means suppose I have to open circuit the branch CD, then I will open the terminals C and D. That is, whatever the connecting wire here, I will open, and at that time, these terminals C and D, the portion between these is open. There is no any electrical connection, and in such case, it is called as open circuit. So, what are the characteristics of the open circuited path? There is high resistance or infinite resistance is present, and current flowing through the open circuited path is zero. Okay. Now, next point, short circuit. Suppose I have to short circuit the branch CD, then I will connect the connecting wire in between terminals C and D. And in case of the short circuit, actually the ideal condition is that we will short circuit this path through the connecting wire, good conducting wire, which is having the zero resistance. That's why whenever I short circuit the path, the entire current will flow through the short circuit path because it is having the zero resistance or negligible resistance as compared to this path. And current always follows the path of low resistance. That's why in case of the short circuit, current flowing through the short circuited path is higher, whereas ideal resistance is zero. Practically some resistance is present, but it is having very less value. Okay, so I hope now you are having the idea about what is the concept of electrical network, circuit element, branch, junction, node, loop, mesh, open circuit and short circuit. Now we'll actually start with the main point, that is Kirchhoff's laws. So what is the Kirchhoff's laws? So Kirchhoff's law is divided into two types. Kirchhoff's current law, which is also called as KCL, and Kirchhoff's voltage law, which is also called as KVL. So first of all, we go through the Kirchhoff's current law statement. So algebraic sum of the current meeting at any junction point in an electrical circuit is 0. And mathematically we can represent as summation of I is equal to 0. Or another one statement, in other words, at any junction or node. Now you are having the idea about what is the junction, what is the node. So at any junction or node in an electric circuit, sum of incoming current is equal to sum of outgoing current. For example, for the junction, current I1 and I3 are leaving the junction, whereas current I2 and I4 are coming towards the junction. So what we can write by applying the Kirchhoff's current law, equation will be I2 plus I4, that is incoming current, is equal to sum of incoming current is equal to sum of outgoing current, that is I2 plus I4 is equal to I1 plus I3. Same equation we can also write as I2 plus I4 minus I1 minus I3 is equal to 0. That is algebraic sum of current meeting at any junction point is 0. Now Kirchhoff's voltage law, which is also called as KVL. So what is the statement? KVL states that algebraic sum of all branch voltages around any closed path in a circuit is 0, which mathematically can be represented as summation of V is equal to 0. Or in some books, there will be statement like in an electrical network, the algebraic sum of voltage drop across various elements, that is IR drop, around any closed loop or mesh is equal to the algebraic sum of EMF in that loop. That is summation of E is equal to summation of IR. Or if we are going to consider the V, then summation of V is equal to 0. So from the mathematical representation, it is clear that in case of the KVL, we have to consider the algebraic sum of EMF and voltage drop. But since we are going to consider the algebraic sum, you should have the idea what are the sign convention. That is when we consider the source of EMF or voltage drop as positive and when we'll consider it as negative. So now we'll consider the sign convention. So first of all, we'll consider the sign convention for voltage drop across the resistors, like for IR drop. So in case of the IR drop, the first point is fall in potential is considered as negative. Now you might be thinking, what is the meaning of fall in potential? So for example, there is one resistor connected between connected in branch AB. If the direction of the current is from from left to right, then we know that conventional direction of current is always from positive to negative direction. That's why we'll write plus on left hand side and minus on right hand side. So whenever current flows, the voltage drop will be IR. But since we are going from positive to negative terminal, that is fall in potential, and fall in potential is always considered as negative. That's why it can be considered as minus IR. Okay, I hope concept is clear. Now rise in potential. So rise in potential is always considered as positive. So what is the meaning of rise in potential? Suppose we are tracing the circuit from minus or negative to positive or from minus to plus, then it can be considered as voltage rise and it can be considered as positive. For example, in this branch, suppose direction of current is from right to left. That means as per the conventional direction of current, we'll write plus here and it is minus. And if we are tracing the circuit from left to right, since we are going from minus to plus, that is rise in potential, which can be considered as positive, that's why voltage drop is equal to plus IR. Voltage drop is equal to plus IR. So we have discussed about how to consider the IR drop positive or negative. Now we'll consider the sign convention for source of EMF. So for sources of the EMF, the statement is if source is traced from its positive terminal to negative terminal. Now how you will identify with which is positive terminal, which is negative terminal in case of source? So the terminals which is denoted by longer vertical line is positive terminal and which is denoted by shorter vertical line, it is a negative terminal. So for this source, this is the positive plus and this is the negative terminal. And if source is traced from its positive to negative terminal, it can be considered as potential drop. Okay, and we know that the drop in potential or fall in potential is denoted by minus. So in this case, the source of EM is minus E because we are going from plus to minus. And another statement, if source is traced from its negative terminal to positive terminal, then it can be considered as potential rise, and potential rise is always considered denoted by plus sign. So for example, in this uh, case, the source of EMP, that is, this is the minus terminal, this is the plus terminal. We are tracing the circuit from left to right, then we are going from minus to plus. That's why this source EMP can be considered as positive, that is plus E. Okay, so till now we have discussed about KVL, Kirchhoff's law statement, and sign conventions. Now we will apply this Kirchhoff's law for network solution, or for writing the equation for the mesh or loop. So for in this network, which is consist of resistor R1, R2, R3, and source voltage is as V1 on left side and V2 on right hand side. So here V2 is not visible. Just keep in mind that this is the V2 source. So what we'll do, whenever we have to write down the equations for these two mesh in this network, what are the two mesh? A, B, E, F, A and B, C, D, E, B. So we'll write down the equations for these two mesh. And by solving these two equations, you will get the value of I1 and I2. So for loop 1 or mesh 1, A, B, E, F, A, will assume direction of current is in clockwise direction and value is I1. So suppose I1 is flowing in clockwise direction in the loop 1. See, in exam there will not be such currents are given that you need to assume. Accordingly, you need to write down the equation. And by solving those equations, we have to find out the response of the network. So what is the meaning of response of the network? Either current flowing through the any element, or find out the voltage drop across the element, or find out the power dissipated by the any element. Then it is called as calculation of the response of electrical network. For example, by solving these two equations, suppose you get the value of I1 and I2, you can easily calculate the current flowing through the any element. Once you get the current into resistance is nothing but voltage drop across the element. And once you get the current square into resistance of the element is nothing but power dissipated by the element. So now, as discussed, we have considered the I1 is flowing in the mesh 1 in clockwise direction, and suppose I2 is flowing in the mesh 2 in anti-clockwise direction. So in this case, current I1 will flow through R1, then through the R2, then through the V1, and current I2 will flow from in upward direction here, then through the R3, then through R2. In this way, it will complete the path. So now we'll write down the equation for the mesh 1 or loop 1, that is A, B, E, F, A. So we'll start with the source. So here current is flowing in upward direction, that is we are going from minus to plus. So first of all, we'll write down these terms. For source, already we are having the plus minus terminal. In R1, current will flow, this current will flow from left to right, and the conventional direction of current is positive to negative terminal. That's why we'll write plus here, minus here. Similarly, same current will flow in downward direction, that is from positive to negative terminal. That's why we'll write plus here, right, minus here. Now we'll apply Kirchhoff's law. So we'll start from the voltage source. In voltage source, current is flowing in upward direction. That is, we are going from minus to plus. That is, it can be considered as potential rise. And hence, this voltage source is denoted by plus V1. So plus V1 into, now this current will flow through the R1. So voltage drop will be I1 R1. But since we are going from plus to minus, that is potential drop, and falling potential is considered as negative. That's why we will write V1 minus R1 I1. Similarly, in R2, this branch is common for mesh 1 and mesh 2. And in this, the current I1 will flow in downward direction, current I2 will flow in downward direction. And that's why the voltage drop will be R2 in bracket I1 plus I2. But since this loop current is or mesh current is flowing in downward direction, that is from positive to negative, potential drop is there. That's why we'll write voltage drop as minus R2 in bracket I1 plus I2. Now there is no any additional element. That's why we'll add summation of E plus summation of IR is equal to 0. And same equation we can write V1 is equal to R1 I1 plus R2 in bracket I1 plus I2. Now we'll write down the equation for the mesh 2. So mesh 2 is B, C, D, E, B, which consists of the element R3, R2 and voltage source V2. Now here we are assuming the direction of the current in anti-clockwise direction. Like this is the plus terminal, this is the minus terminal of the source. Current is flowing from right to left. So here we'll denote plus and here minus. Here current is flowing in downward direction. That's why we'll represent this as positive. This is the negative, and then no any additional element. Now while applying the KVL, we'll start with the source voltage V2. Since current is flowing in upward direction, that is we are going from minus to plus, and that's why it can be considered as potential rise. And that's why we denote it by plus V2. So plus V2. Now here current is flowing from right to left, that is plus to minus. That's why voltage drop will be considered as potential drop or falling potential, and this voltage drop will be denoted by minus sign. So voltage drop is R3 into I2, so it is denoted by plus V2 minus R3 into I2. Similarly here, this current I2 will flow in downward direction, and since here two currents I1 as well as I2 flowing in downward direction, that's why voltage drop is R2 in bracket I1 plus I2. But we are going from plus to minus, and that's why voltage drop will be denoted as minus R2 in bracket I1 plus I2 is equal to 0. And same equation can be written as V2 is equal to R3 I2 plus R2 in bracket I1 plus I2. That is equation number 2. Now you need to solve these two equations by using the Cramer's rule. So what is the Cramer's rule? How to utilize to solve the equations, that we'll discuss in the next part of the video lecture. But now in this case network there are two mesh. If there is three mesh network, then you will get the three equations. Those three equations you can solve using the Cramer's rule. You will get the value of individual current, and by using that value of current, we can easily calculate the voltage drop across the element or power dissipated by the particular element. And this process is called as finding out the response of electrical network. Thus, in this video lecture, we have discussed what are the Kirchhoff's law, what are the basic terms related to the electrical network, then sign conventions, and how to apply the Kirchhoff's law to get the equations in case of the mesh or loop analysis. So in next video lecture, we'll discuss about actually numericals and Cramer's rule. Okay. So with this, we'll stop the lecture. Those who are new to this channel, please subscribe the channel. Thank you.